Alright, so in the last video we went over the brute force method and why that is a problematic solution. So now what we're going to do is we're going to try to see if we can find a path that will be relatively short. It won't be the shortest distance, but it will be a good approximation. The way that we're going to do that is it's going to be really simple. It's going to take the map that we drew. Let's see if I can bring it up right now. Oh, this is the wrong problem. Bring up this one. So we're going to take up... So this is the map we drew. And what we're going to do is between all these cities, we are going to draw a path to the closest city. So part of the rules says that the starting node needs to be the North Pole, which is the city with index 0. And the last node needs to be the city with index 0. So what I'm going to do is I'm going to write code that starting at 0 will connect the dots to whatever closest node. It will connect to the closest node and do that for all of these until it gets back to the North Pole. So I'm going to do that now. Alright, so I finished the code. One thing I want to do right now is I wanted to show what we had from the first entry of the random route, just so that I can compare it. So we're going to begin the program running. So this is our map, and I'm going to begin the process. Okay, so this is what we have here. So you can see that this path is not organized at all, and it looks like it's really quite random. And it's going to be quite long, and I think our submission shows that. I think there's only 8 groups that we beat. I think it was like 1,190 something place overall. So we're going to try to improve that. So I programmed in another method that will connect each dot to the closest dot next to it. And we're going to see this map is going to look very different. Okay, so you can see this map looks very, very different than our last map. You can still see the picture in the background, and you can see the jumps are nearly as long. In fact, you know, they really are to the closest node. Although not always, because the way that the algorithm works is the moment a node is connected, it's taken off of the list of nodes that need to be connected to, obviously, because it's already on the path. And you can see, like, down here, there are incredibly large jumps because there are nodes that are, like, ignored in a certain area. And then as the path keeps going and paths are formed around it, that node that was ignored is finally the closest one, and a huge jump is made. So there's tons and tons of ways that this can be improved. And one thing also to mention is that this doesn't take into any account the prime numbers. Now, with this challenge, one of the restrictions is that every 10th city needs to be a prime number. So, like, has the index of a prime number. So, if that is not the case, then there will be a 10% penalty on the distance. So, I'm going to code in to see where the prime numbers are distributed. So that's pretty clear to see. Okay, so now we can go back, and I reprogrammed so we can see the prime numbers really easily, so we're going to try that now. Alright, so there we go. So you can see this picture here. It looks a lot more red, but really what you're seeing is I programmed it such that any prime city will appear as red. So you can see they're pretty evenly distributed here. One thing that's interesting to note is that it looks like they are more common in this darker area right here near the reindeer's head, and less common over here, but overall it appears they're pretty evenly distributed. It doesn't look like there's very many over here. There's a lot over here. So where there's high density of cities, there appears to be a higher density of prime cities, which makes a lot of sense. So what we're going to do now is I'm going to reprogram the closest node algorithm to connect to the closest node if it's not one of the 10th steps, and if it's on a 10th step, connect to the closest prime number, and we're gonna see how that does. Okay, so as you can see here, this program came out with a path kind of similar to the last one, but it's also kind of a combination of the last one and the random one, because you can see the jumps are a lot longer in this one in certain places. And obviously the reason for that is it needs to jump to the closest prime number. So now that we have this, what I'm going to do is I'm going to submit this and see where we stand here. Alright, so looking at the leaderboard, looks like we're up to 832. Oh, that's pretty good. I mean, considering we were all the way down here before. So clearly picking the closest node and looking at the primes, that definitely helps. There's still a lot to work on here, and the next thing I'm going to do is I'm going to be working on some new optimization techniques, and possibly, I'll have to think about it, but maybe implement some sort of machine learning approach to this. Actually, one thing I want to note here, I just realized, this is not an improvement. I actually submitted one before using the same algorithm just to make sure this will work, and the one that I submitted before did not include the prime numbers. This one did. So clearly a 10% penalty was not really a heavy enough penalty, and just picking simply the closest route is actually results in a shorter route than having to deal with prime numbers for now, just using these raw numbers. But I'm still going to have to look at these optimization techniques and possibly machine learning to make this route even shorter.